Dear students, after studying this module, you shall be able to know the importance of amines and related compounds. Design the synthesis of amine compounds using reduction of nitro compounds. Design the synthesis of amine compounds using reduction of amides. And finally, design the synthesis of the amines using reductive amination. The aliphatic and aromatic derivatives of ammonia are known as amines. They are weak bases and possess unshared electron pair on nitrogen atom. The amines are classified based upon the number of alkyl or aryl groups attached to the nitrogen atom. It is shown here in the figure the different type of amines. Those amine compounds that have only one alkyl or aryl group attached to the nitrogen atom are primary, while those with 2 or 3 alkyl or aryl groups attached to the nitrogen atom are secondary and tertiary respectively. The quaternary amine compounds possess 4 alkyl or aryl substituents. Their derivatives of amines are very important to humankind and present in many pharmaceutical molecules. This makes their synthesis extremely important. Synthesis of amines by reduction of nitro group. The nitro group can be reduced to amines using various reducing agents like 10HCl, palladium carbon with hydrogen, lithium aluminum hydride represented as LiAlH4, Rann nickel, etc. Let us look into the synthesis of aniline. The retrosynthetic analysis. The amines like aniline can be obtained from nitrobenzene. The functional group interconversion of amines from nitro group is shown here in the figure. Nitrobenzene can be reduced to aniline using 10HCl as a reducing agent. The conversion is a simple and a direct approach. Synthesis of N,4-hydroxyphenylacetamide. Looking at the retrosynthetic analysis of N,4-hydroxyphenylacetamide, it takes place through various functional group interconversions. The first step involves the cleavage of the carbon-nitrogen bond, which on further functional group interconversion forms a phenolic amine, that is 4-aminophenol, which can be traced back to phenol as the starting material. Synthesis. The synthesis of N,4-hydroxyphenylacetamide takes place in 3 steps starting from phenol. Firstly, phenol on nitration using nitrating mixture, which is HNO3 H2SO4, forms 4-nitrophenol. 4-nitrophenol is reduced in the second step to 4-aminophenol using 10HCl as a reducing agent. 4-aminophenol is acetylated in the step 3 using acetic anhydride and forms N,4-hydroxyphenylacetamide. Synthesis of 4-bromophenylamine. Retrosynthetic analysis. The disconnection approach for the synthesis of 4-bromophenylamine suggests that the functional group interconversion plays important role for its synthesis. The retrosynthetic analysis, as shown in the figure, shows the disconnection require initial functional group interconversion to a N,4-bromophenylacetamide. It can be seen how a bromoaniline undergoes carbon-bromo cleavage forming amide, which is traced back to amine and finally to nitro as a starting material. Looking at the synthesis of 4-bromophenylamine can be done in 4 steps starting from the simple reagent nitrobenzene as discussed in the retrosynthetic approach. Nitrobenzene is reduced to aniline using tin HCl as a reducing agent. Aniline is then acetylated using acetic anhydride to form N-phenyl acetamide. N-phenyl acetamide is brominated using bromine to N,4-bromophenyl acetamide. In the last step, N-bromophenyl acetamide is then hydrolyzed to 4-bromophenylamine. Synthesis of amines by reduction of amide group. Amides, represented as R C double bond O N R2, can be reduced to amines, that is R CH2 N R2, by conversion of a carbonyl group to a CH2 group using lithium aluminium hydride or sodium borohydride as a reducing agent. The retrosynthetic analysis of benzylamine can be easily explained by functional group interconversion as represented in figure. Benzylamine is obtained from benzamide, which can be obtained from benzoyl chloride and ammonia. The synthetic steps for benzylamine synthesis are: step 1, benzoic acid on reaction with thionyl chloride forms benzoyl chloride. In the step 2, benzoyl chloride on reaction with ammonia forms benzamide. The benzamide on further reduction with lithium aluminium hydride followed by hydrolysis forms benzylamine. Let us look into the synthesis of benzylphenylamine. The retrosynthetic approach says the benzylphenylamine can be synthesized by the reduction of N-phenylbenzamide as seen from the given figure. The cleavage of the C double bond O N bond takes place, leading to the formation of the two precursors, which are the acid chloride and the aniline. Synthesis of benzylphenylamine is shown in two steps as shown here in the figure. The step 1 involves the reaction of benzoyl chloride with aniline in the presence of a base to form N-phenylbenzamide. In the step 2, the N-phenylbenzamide on reduction with lithium aluminium hydride followed by the hydrolysis gives benzylphenylamine. Let us look into the synthesis of N-benzyl 1-phenylethanamine. The retrosynthetic analysis of N-benzyl 1-phenylethanamine is shown here in the figure. The functional group interconversion on the target molecule shows that this molecule can be synthesized from N1-phenylethylbenzamide. Further, disconnection of N1-phenylethylbenzamide is possible due to the cleavage of carbonyl NH bond. As a result, the reaction can be traced back to ammonia and acetophenone as the starting reagents. The synthesis of benzyl 1-phenylethylamine is shown here in the figure. The target molecule can easily be synthesized from the simple starting material ammonia and acetophenone as shown here in the disconnection approach. In this step 1, acetophenone on reaction with ammonia under the acidic conditions form 1-phenylethylamine. In the step 2, 1-phenylethylamine on reaction with benzoyl chloride in the presence of a base forms N1-phenylethylbenzamide. In the step 3, the N1-phenylethylbenzamide formed undergoes reduction with a reducing agent like lithium aluminium hydride followed by hydrolysis to form benzyl 1-phenylethylamine. Synthesis of amines by reductive amination. The reductive amination is also known as reductive alkylation. It involves the reaction of carbonyl group of aldehydes or ketones with ammonia. Primary aliphatic amine or primary aromatic amines in the presence of the acid catalyst. Normally, the pH ranges less than 4 to form the imine intermediate. The imine intermediate so formed is reduced to amine using a reducing agent. Let us look into the synthesis of cyclohexylamine. The retrosynthetic analysis of cyclohexylamine is given in figure. The functional group interconversion on cyclohexylamine gives the corresponding imine as shown here by the cleavage of the corresponding amine. The reaction starting materials can be traced back to cyclohexanone and ammonia. The synthetic pathway involves in the step 1 the reaction of cyclohexanone with methylamine to form an intermediate imine. In this step 2, the intermediate imine so formed in the step on catalytic reduction with palladium carbon and hydrogen forms the product 1-methyl cyclohexylamine. Synthesis of dicyclohexylamine. Retrosynthetic analysis of dicyclohexylamine is shown in figures. The FGI shows that the target molecule can easily be obtained from the corresponding imine as discussed in the examples. The disconnection of C double bond N of an imine gives the starting materials as cyclohexamine and cyclohexanone. The synthetic approach involves the reaction of cyclohexylamine and cyclohexanone to form the intermediate imine in the step 1. The intermediate imine on catalytic reduction with palladium charcoal and hydrogen forms the final product dicyclohexylamine in the step 2. To summarize, the aliphatic and aromatic derivatives of ammonia are known as amines. They are weak bases and possess unshared electron pair on nitrogen atom. Nitro group can be reduced to amines using various reducing agents like tin HCl, palladium charcoal and hydrogen, lithium aluminium hydride, ranitidine, etc. The retrosynthetic analysis of amines and related compounds take place through various functional group interconversions. Synthesis of aniline, N4-hydroxyphenylacetamide, 4-bromophenylamine and other amine related compounds have been explained. Amides can be reduced to amines by conversion of a carbonyl to CH2 group using lithium aluminium hydride or sodium borohydride as a reducing agent. The amines can also be synthesized by reductive amination.